In this video, we will introduce the fundamental concepts, operational procedures, and customizable features involved in constructing a geological model. The geological model demonstrated in this program is constructed using an algorithm proposed by Alan M. Lemon in 2003. The core concept involves importing borehole core data, then determining the depositional sequence of borehole materials to assign horizon IDs from the bottom up. Next, a site-wide two-dimensional grid called the primary TIN is generated based on the boundary extent. For each geological layer, elevation data from the boreholes are interpolated onto this grid to form surface meshes, known as TINs. Finally, the elevation of each mesh node is updated from the bottom layer upward, accounting for overlapping conditions, and the three-dimensional geological solids are generated layer by layer. When you open the program, start by creating a new project. Click on Project in the top left corner, then select New. In the model type selection, choose 3D. Once the new project is created, you're ready to proceed. You'll see 4 groups on the main screen. Click on the first one, Site Conceptual Model Information GUI. To start building the geological model, first click on the Wizards button at the top menu of the application. Then, select the second option called Solids Wizard. The data needs to follow the specific sequence. You begin by setting up the boreholes, then configure the TIN, and finally set up the solids. Once all the icons on the left panel light up with green color, it means everything is ready and the geological model can be generated. Next, we'll import the borehole data. Start by clicking on Import Borehole Data. Then click Select to choose your file. You'll need to prepare a text file in the correct borehole format, either a .txt or .csv file. This file should include information about each geological contact point along the boreholes. For each point, you need to provide the name, the x and y coordinates, the elevation or z value, the material name, and the soil ID. Now let me explain how the soil ID is assigned. As shown in the figure here, the soil ID must be a number. It refers to the material that lies below that node. However, if the node is the deepest point of the borehole, then the soil ID should represent the material above the point. Let's go back to the previous panel. You can specify the file format, choose the fields and record options, and configure the fields mapping. There's also an option to let the program automatically calculate the absolute elevation for each point. Finally, click Add to import the borehole data. If you want the software to determine the depositional sequence for you, simply click on Assign, then select Auto Assign Horizon. This will automatically generate the correct stratigraphic order based on your data. Once you're done, click Save to complete the import process for the borehole data. Next, we proceed to the setup of the TIN, Triangulated Irregular Network, which constructs a two-dimensional triangular mesh based on the previously imported borehole data points. To begin, we select TIN and then open the format settings. Within this interface, there are 3 available methods to define the mesh boundary: extent, convex hull, and boundary file. The extent option allows the user to manually define a square or rectangular boundary by specifying its dimensions. The convex hull option automatically generates an approximate boundary that encloses all the data points. Alternatively, the boundary file option enables the user to import a predefined boundary file. In this demonstration, we use the boundary file approach. After loading the boundary, we click Simplify Boundary for mesh quality concern. This function redistributes the spacing between the boundary nodes. Since the boundary consists of multiple points, setting the spacing too small may result in an overly dense mesh. Based on previous experience, a spacing of 1,500 units is optimal for this dataset, so we input that value. After configuring the boundary settings, we proceed to generate the mesh by selecting Create TIN. The mesh engine provides 2 options: Default and Mesh Gen. While Mesh Gen offers advanced customization features, for this case, we choose the default engine for simplicity. Finally, clicking Create initiates the generation of the two-dimensional triangular mesh. Finally, we move on to constructing the three-dimensional geological model based on the two-dimensional triangular mesh we created earlier. After switching to the Solid window, click on Create Solid. Within this panel, you can choose from a variety of interpolation methods depending on the characteristics of your dataset. Once the settings are configured, simply click Create, and the 3D geological model will be generated. In the Resources browser, located in the upper left panel, you can toggle the visibility of elements such as boreholes, boundary, tin, and solid. For instance, turning off certain solids can help you better observe the internal structures of the model. Similarly, hiding the outer boreholes allows for a clearer view of the boreholes located toward the interior. By the way, you can hold the left mouse button to rotate the model, scroll the mouse wheel to zoom in or out, and hold the mouse wheel to pan the model. Clicking the top-level file allows you to toggle all the data on or off at once. Additionally, by right-clicking on any solid object, you can choose to export the file directly or send it to GMGUI for further processing. The Properties Editor window offers extensive customization options for refining the visual and structural presentation of the model. For example, by selecting all resources from the Resources browser, you can modify parameters such as the background color and orientation of the view. If you need to change the diameter of the boreholes, select the Boreholes section in the Resources browser, choose the imported file, and navigate to the Properties Editor at the bottom. In the section labeled Miscellaneous, you'll find an option to adjust the radius. Furthermore, selecting boreholes, boundary, tin, or solid allows you to edit various visual properties such as color maps, information labels, scalar bar text, translation, and more. Let me give you a brief introduction to some features. On the screen, I'm changing the colors. You can modify the label colors from the Label menu. From the Boundary menu, under Rendering, you can adjust the transparency. In Miscellaneous, you can change the boundary color and thickness. Switching to the tin view, you'll find the same set of options available. Finally, when you switch to the Solid interface, you can use the Color Map menu to turn the scale bar on or off. These settings enable users to fully customize the appearance, text size, visibility, and spatial positioning according to their specific preferences. Thank you for your attention.